So now talking about the refractive index, light travels very fast. As far as we know, nothing can travel any faster than light yet, okay? So the speed of light as it travels through empty space is exactly 299,792,458 meters per second. This fundamental quantity is given its own symbol C. For most purposes, we can round off the value to 300 million meters per second, okay? So we can write here the speed of light, okay? We can use it, this one, all right, 300 million meters per second. All right, so when a ray of light passes from air into the glass, for example, like this one, okay, what happens now? It slows down and bends towards the normal. So the quantity that describes how much light is slowed down is the refractive index. So if the speed of light is halved when it enters a material, for example, the refractive index is 2, and so on. Hence, we can write an equation for the refractive index, N of a material, okay? So now, how do we do it? So refractive index okay, we can use this N. Okay, now N is equals to the speed of light in a vacuum divided by the speed of light in the material, okay? Speed of light in a vacuum, okay, over speed of light in a material. So water has a refractive index 1.33. This means that light travels 1.33 times as fast in a vacuum compared to its speed in water, okay? So it is important to remember that refractive index is just a number. It has no units, okay? This is because it is one speed divided by another. The units cancel out, okay? There is a law that relates the size of the angle of refraction to the angle of incidence. This is Snell's law. It also involves the refractive index. Since the greater the refractive index, the more a ray is bent. Okay, so the law is written in the form of an equation. Okay, so we have here M is equals to sine angle of incidence over sine angle of refraction. Okay, so from the experiment that we did a while back, we can actually find the refractive index of the material. So in that case, this perspex. So we can find the index of refraction of this perspex using the data that we have gathered. And the data are, we have the angle of incidence, okay? And what was the angle of incidence? Okay, now using this equation, we can have sine 34 degrees. And what was the angle of refraction? It was actually smaller because it goes towards or closer to the normal, all right? Which is a sine 23. And therefore, sine 34, we have 0.55 divided by 0.39, all right? Which will give you 1.4, all right? Okay, so therefore, the index or the refractive index of this perspex is 1.4. Again, no units needed. Actually, we can play around with this formula, with this equation. What if we are asked to find the refractive index and we are not able to measure the angle, okay? What was given is the speed of light in a vacuum and the speed of light in a material, for example. So now we can have it like this. N is equals to, what is the speed of light in a vacuum? Then we can have 3.0 times 10 to the 8 meter per second. And what is the speed of light in a material? So I have just shown you the speed of light in some transparent material. Okay, so in this case, we have 2.0 times 10 to the 8 meter per second. That is the speed of light in a material, okay, in a regular perspex. Okay, take note that here we use 2.0 times 10 to the 8 meter per second as the speed of light in a material such as this perspex. So this actually is the measured speed of light of a certain perspex. So it may vary actually depending on the type of material, because even the perspex, we cannot really have 100% identical material. So let us just use this, okay, speed of light, okay. So therefore, let us divide 3.0 times 10 to the 8 meter per second divided by 2 times 10 to the 8 meter per second. And this will give you 1.5. Therefore, the index or the refractive index of a perspex whose speed of light is 2.0 times 10 to the 8 meter per second will be 1.5. As you can see, it's pretty close, 1.5 and 1.4. So that's it for today. I hope we have achieved our objectives for today. Till next time, again, this is Mr. Tom saying, there's power in physics, and physics is power.